this lecture, I will explain what is a voltage regulation of a transformer. So before that, from the previous lecture, what is R01? That is the total resistance when referred to primary, and the X01 is total leakage reactance when referred to primary. R02 is R2 plus R1 dash. The X02 is equal to X2 plus X1 dash. If you know the resistances, a total resistance when referred to primary or total resistance when referred to secondary, we can find the drop in the transformer windings. Then we can calculate the voltage regulation. In order to know the performance of the machine or performance of the device, we require two indices. One is the regulation. Performance indices are, one is regulation and another one is efficiency. If you go for the motors, we can calculate the speed regulation. If it is a generator, we can calculate the voltage regulation. For a transformer, we should concentrate on voltage regulation. So your equivalent circuit will be like this with respect to secondary. So this is E2. The load we are connecting like this. The current which is flowing through the load is I2. The voltage across the load is V2. So by neglecting the no load branch, this is the equivalent circuit after induced EMF. And we can write it as E2 is equal to V2 plus I2 into Z02, where Z02 is equal to R02 plus J times of X02. So V2 plus I2 R02 plus J times of I2 into X02. The voltage regulation can be defined as, it is a change in secondary terminal voltage from no load to full load. That means here the switch is provided. If the switch is under open circuit condition, let us say the voltage will be, now it is E2. The terminal voltage is now V2 is equal to E2 under no load condition. Under no load condition, the I2 value is 0. I2 value is 0. Substitute here, this V2 is equal to E2. Minus, under full load condition, that secondary terminal voltage is V2 and it is expressed as a percentage fraction of no load secondary terminal voltage and multiplied with 100. Then this is called voltage regulation. V dot R is called voltage regulation. It is a change in secondary terminal voltage from no load to full load, and it is expressed as a percentage fraction of the no load secondary terminal voltage. That is called the voltage regulation definition. So we are having a different types of loads. One is RL load, lagging load, leading load, and resistive load. That is called the unity power factor load. For a lagging power factor, we should derive the derivation for a voltage regulation. Now let us see. I will take the reference as the secondary terminal voltage V2. With respect to V2, the I2 is lagging for a lagging power factor load at an angle of phi 2, where phi 2 is called the secondary power factor angle. Secondary power factor. With respect to V2, I2 is lagging. See the equation. we are adding I2 Z2 component to V2, then only I will get E2. So I2 R2 component is added to V2. The I2 R2 component is in phase component, or which is parallel to I2. In phase component to I2. What do you mean? Means it is not in phase with V2. This I2 R2 component which is parallel to I2 because it is a resistive component. And J means we know that 1 at an angle of 90 degrees. I2 X2 component which is I2 X02 component. This is I2 R02 component. We are taking the total resistance from upper to secondary. By adding these values, then I got the E2. Again we will check it. E2 is equal to V2 plus I2 R02 plus I2 X02. Let's say this is O A and extend this line, and from this O point draw a arc to the E2 line. So let us assume this one is E point. The point OE is equal to, the length of OE is equal to E2. Extend OA line, okay, extend OA line. From this O point draw an arc, then it will touch the point here. So draw a perpendicular line, neglect this small portion, So here draw a perpendicular line. So this is 90 degrees. The angle between the V2 and the I2 is phi 2, and V2 and I2 R02 is also phi 2. If I am taking this small triangle, this one is B now, let's say this is C, ABC triangle, A, B, and this one is C. Angle BAC is phi 2 now, and the C is angle is 90 degrees. What is this angle? Is 90 minus phi 2. So this angle is 90 minus phi 2. But what is the angle between I2 R02 and I2 X02? I2 X02 is exactly 90 degrees. Add these, then you will get the 90 degrees. So this small portion and small portion, okay, from this total 90, if you subtract the 90 minus phi 2, 90 minus of 90 minus phi 2, then I am getting the phi 2 value. Once again, it's a very important concept. The angle between the I2 R02 and I2 X02 is exactly 90 degrees. See here, it is 90 degrees, but this small portion is 90 minus phi 2. If I want to get the 90 degrees, means how much term, which term is added to get 90 phi 2 term? That is one method. Or I need this small portion. From this total portion, if you subtract the small portion, then remaining I will get. So that's why 90 minus of 90 minus phi 2 is, this angle is now phi 2. So using mathematical concepts, so this is phi 2, and now this angle is also phi 2. Yes, this angle is also phi 2. And from this C point, extend this line, it will touch us at D point, and here it will touch us at E point. and the BE value should be equal to CD. The length of BE is equal to length of CD. Now OE is equal to OA plus AB plus B. OA plus AB plus B is equal to CD. Here one right angle triangle is formed. So this is a right angle triangle is formed. Right angle triangle is formed. And this is a sin phi 2 opponent. So this one is I2 x0 2. The hypotent value is I2 x0 2. Then sin phi 2 is equal to from this E, and this one is C, and this is D. Let us say this already E is assigned for top one, right? F. You can assign a F term in order to avoid the confusion. The length of BF is equal to length of CD. Sin phi 2 is equal to CD divided by I2 x0 2. From this I am getting I2 x0 2 sin phi 2. See, already E is assigned here. That's why I am taking the F. Length of BF is equal to length of CD. What is the OA value? The OA value is V2. OA value is V2 plus AB. What is the AB? Again we are having one more triangle, cos phi 2. For this triangle, cos phi 2 is equal to AB divided by hypotenuse is I2 into R02. Yes, this AC length, the length of AC, this is called the hypotenuse, is I2 R02. We have to calculate the AB length. The AB is equal to I2 R02 cos phi 2. So now substitute here I2 R02 cos phi 2 plus CD. What is the CD value? We are already derived. That is I2 x02 sin phi 2. I2 x02 sin phi 2. The OE length is equal to OF length by neglecting the small portion, that is called the E2. Now E2 minus V2 is equal to I2 R02 cos phi 2 plus I2 into x02 sin phi 2. So what is the percentage voltage regulation formula? Percentage voltage regulation is E2 minus V2 by E2, then I2 R02 cos phi 2 plus I2 x02 sin phi 2 divided by E2. So plus R minus, plus is for lagging power factor, minus is for leading power factor. Once again listen, this phasor diagram is very very important. I am taking the reference is OA line, that is V2. With respect to V2, I2 is lagging for a lagging power factor of the load, and I2 R02 component is parallel to I2. I2 x02 component is perpendicular to I2 R02, and I add this one, then I am getting the E2 value. And from this point OE, take this dry line arc, and it will touches the point here. Extend this line AB F line and neglect this small portion, and this angle is phi 2 and this angle is 90, and whatever the remaining angle is 90 minus phi 2 if you take this triangle. After that we know that the angle between the I2 R02 and I2 x02 is exactly 90 degrees. From this 90 you subtract the 90 minus phi 2, then I am getting the phi 2 angle. This angle is also phi 2 using a mathematical concepts. then the length of BF is equal to length of CD. From this one triangle we can get the AB length, and from this ECD triangle we are getting BF length. Then add and subtract, then you will get the voltage regulation formula: I2 R0 to cos phi 2 plus or minus I2 X0 to sin phi 2 divided by E2. For a leading power factor of the load, this is a phasor diagram. With respect to V2, I2 is leads at an angle of phi 2. The I2 R2 component is parallel to I2, and I2 X02 component is perpendicular to I2 R02. Okay, I2 R02. Then from this O point you add this one, then this point is called the E2. So project this. So project this. I am here also like this. From this we are getting the formula is I2 R0 to cos phi 2 minus I2 X0 to sin phi 2 divided by E2. That is for leading power factor. Okay. So with respect to V2, I2 is leads at an angle of phi 2. The E2 should be like this. Okay. This is a voltage regulation of a single phase transformer.